Hello everybody, System Chalk here. We're going to be doing something a little bit different for this channel, but I thought this might be a bit fun to try out. So there is a subreddit called RoguelikeDev. It's actually something that I found a couple of interesting games that I've followed from. And I might talk a little bit at the start in terms of why I was looking for this in the first place, but I maybe should try and introduce what this series is going to be about. This RoguelikeDev subreddit does an annual event called RoguelikeDev does the complete roguelike tutorial, and in this case, it's 2024. Now, it's not, as you can, well, actually see at the top, it's July 20th, so I am quite late in getting started. But this is about the closest that I have gotten to finding out the event has been going, and having the urge to join in. So I've decided that it is something that I want to do this year, and I thought one thing that's kind of nice, both as a commitment mechanism, but hopefully something that other people might find interesting, and I'll maybe try and unpack why people would find this interesting, because there's going to be a subset of people who actually find this frustrating. But I thought a nice thing to do would be to do a video series of this. So first of all, one of the reasons why I was browsing around this subreddit is I've had a bit of a weird kind of path to roguelikes. I think the thing that really interested me the most about roguelikes, as in full-on descendants of the game Rogue, I'm not going to get into stuff like the Berlin interpretation and all of that, because I actually tend to find that sort of stuff off-putting in terms of trying to get into this. But I remember a story that Ryan Clark told about the origins of Crypt of the Necrodancer, which is a game that I really enjoy. And I think the idea here was that he was interested in Rogue and games like Rogue, but he felt that one way that they could be improved is to get past this idea that, you could sort of get up and watch a movie and have dinner and, go for a run and come back and nothing would change about the world. And I think, again, I don't think this is hidden. The Brace Yourself stuff is really fun to watch and available online. But I think the idea here was that the original idea was for there to be sort of a timer in which you would need to make a move. And he has this realization that it kind of looks like the character is dancing. And then, I certainly don't mean to imply that the path to realizing Crypt of the Necrodancer was an easy one. But sort of from there, adding some music and a lot of those things that make that game very special sort of followed. And my usual experience of roguelikes have tended to be the sort of second or third tier of descendants. So I'm thinking a little bit more along the lines of something like A Risk of Rain, which I think takes a lot of the features that people like out of those types of games, but applies them to a new type of game, right? So one wouldn't normally think, looking at Rogue, to do some sort of platforming shooter. Or something like Binding of Isaac, which seems to take some things from the Legend of Zelda games. I've only ever played that Link's Awakening, I think. It was one on a Game Boy. But I know it was re-released to the Switch, but I think it was originally on Game Boy. But anyway, these are sorts of things where I really get to appreciate them in reverse. But on the other hand, I also think there's something to be said for how this has become very inspiring for a lot of people. I also think that Diablo was trying to sort of take the mantle of Rogue and move forward with it. And I think they did so in interesting ways. In fact, if you look at the original design document, there seemed to be an idea of selling new weapons through like discs that would be impulse purchases at stores, probably. I'm guessing not a supermarket or something like that, but maybe. But yeah, I mean, this is DLC before we have any kind of digital distribution. I think that sort of stuff is always interesting to see. So my own personal feelings are that the one thing that I've not been crazy about for a lot of game development has been sort of a very backward-looking kind of approach. I think there is a difference between being inspired by things or working within a set of conventions versus, sort of taking something whole and, just putting a new coat of paint on it or something like that. I think I'll probably get into a little bit of trouble whenever I talk like that, because there's quite a bit to be said on that. And I don't think that's exclusive to roguelikes, or games for that matter. But it's something I've been thinking about for a while in terms of the things that I enjoy and some cases where I maybe feel that we're not doing as much as we could. But maybe that's something to talk about at a later time. But I do think, even if I am going to maybe offer a critique along those lines in terms of some games, it would be good to at least be able to understand where people are coming from. And then on top of that, I think there is something to be said for the fact that there are a lot of games that I've really enjoyed, which are not just simply redoing or kind of putting a new coat of paint on an old idea. But they are really seem to be doing something new and building off of that and using it as a source of inspiration. And so, again, there's something about this genre that seems to be a very fertile ground for game developers. And so naturally, I think that's a place to look and be interested and practice. I guess the other thing I wanted to mention too is that I do tend to find that I will, do some kind of writing. I was actually kind of interesting. It was, I think, Tim Kaine. He worked on the Fallout games. He talked about being involved in the game industry, and he said, maybe you don't need to, maybe your involvement in the game industry isn't to be a game developer. Maybe it's to be a pundit, which I find very fun because I do writing on games. And I have actually put something out on Itch. It was a collaboration with somebody. But I do very frequently find that the reaction that I get for a lot of things that I will write will often be, well, you're not in the games industry, so you can't have an opinion, or something along those lines, or what do you know, or what have you. I actually disagree with the premise of the complaint. So, I don't turn around and say, well, I do actually have some credits on things, because in the end, that's just going to push the goalpost. But I think another reason why somebody might want to do this is that if you run into the accusation, well, you haven't made a game, so you can't have an opinion. Here you go. You've got a wonderful opportunity here to make a game, and then you're allowed to have an opinion. I can't guarantee that the other party will listen to you, but this is my opportunity to really show the world that I'm allowed to have opinions on things. Anyways, we're getting close to about 10 minutes of introductory material. In the end, I probably could just condense all of that and say, this is all just very interesting to look at. And I thought having a little bit of a document of going through the process, especially as I try and catch up to where the current group is, might be kind of fun. And it's a chance to talk a bit about some of the things that maybe the tutorial doesn't cover. I should also mention too, I have not done this tutorial yet. So I think I maybe took a few early steps on it, but we will we'll run through. I'll read this is a pinned post, by the way, if you go to our RoguelikeDev. RoguelikeDev does the complete roguelike tutorial starting July 9th, 2024. RoguelikeDev does the complete roguelike tutorial is back again for its 8th year. It will start 1 week on Tuesday, July the 9th. The goal is the same this year, to give roguelike devs the encouragement to start creating a roguelike and to carry it through to the end. Like last year, we'll be following, and then this is the link. I've already got it up in another tab here. The tutorial is written for Python and libtcod, but if you want to tag along using a different language or library, you are encouraged to join as well, with the expectation that you'll be blazing your own trail. The series will follow a once-a-week cadence. Each week, a discussion post will link to that week's complete roguelike tutorial sections, as well as relevant FAQ Friday posts. The discussion will be a way to work out any problems, brainstorm ideas, and share progress, and any tangential chatting. If you like, the Roguelike Dev Discord's #RoguelikeDev-help channel is a great place to hang out and get tutorial help in a more interactive setting. I've not joined the Discord yet, by the way. Hope to see you there. Runs from July 9th to August the 27th, and then a bunch of comments down here. and then you can check out the other posts here and see some of the other people following along. So the first thing that I want to say is that this is, because this is the first year that I'm going to be doing this, and I am actually a little comfortable with Python. I won't say I'm an expert or anything like that, but I am going to be doing just a vanilla run of the yet another roguelike tutorial. Now, with that in mind, I think there is something to be said about getting inspired. So if something happens to come up where I really feel like it's natural to add an extension, I'm probably not just going to leave that to a comment. I might actually allow that to go through. And I think one of the reasons why I want to record this is that anytime I've had a good idea for something, I try to have the presence of mind to remember what were the conditions under which I had that idea. That's just something I'm really interested in. I do read books in terms of creativity. I'm usually more interested by people whose works I'm interested in. So Arthur Koestler, for instance, wrote a book on imagination and creativity. So that sort of thing is a little bit more interesting to me than someone who, is just writing something about, ideas, and it may or may not have any relation to reality. But this is one of the reasons why I think having a record is sort of useful. So I will click you. If you click on the link here, it will take you to this page. So yet another roguelike tutorial written in Python 3 and Tcod. So I am, there's actually another excuse for me to do this, which was every once in a while I get this sense of masochism, and I make a virtual machine with some variant of Linux, and then I try a couple of things just in terms of setting up usually my analysis tools and such. And I tried a new little setup script that I wrote. It didn't fully work, but that's neither here nor there. But this was a chance for me to say, it's like, okay, well, let's try a real project. And this time I'm not going to do something data analysis. Let's just try and make something. Let's try and make something from scratch. So this does mean that I'm going to have a couple of variations on the instructions just because of the way that I usually set things up. And with that in mind, I have done a few things. So one of the things I wanted to actually try and do is do this on a Raspberry Pi, but I didn't have a really good idea about how to record the video doing that. I don't think it's impossible. I just think it would have been a little more difficult. So in this case, I'm just doing a virtual machine that I set up using Hyper-V. There's also a tool from Oracle called VMBox, but I have this with Windows already, so I just use that. And this is Fedora 40, but I actually noticed that in setting up the instruction, or no, sorry, I think it's the Tcod instructions. They actually have them for Debian. So if there is a problem, I'm probably going to have to do a little bit of work on that. So anyways, setting up. Prior knowledge. This tutorial assumes some basic familiarity with programming in general and with Python. If you've never used Python before, this tutorial could be a little confusing. There are many free resources online about learning programming and Python, too many to list here, and I'd recommend learning about objects and functions in Python at the very least before attempting to read this tutorial. Of course, there are those who have ignored this advice and done well with this tutorial anyway, so feel free to ignore that last paragraph if you're feeling bold. Now, again, I'm going to be in this introductory one because for some people, like I said, it's going to be tedious for some people. Taking the time to watch somebody set up their environment, particularly if it's not an environment that you're operating in, to me, this is just going to be frustrating. And of course, people who know all of this stuff are going to just see the mistakes, which, tends to lead to regrettable comments on YouTube channels that get deleted. But I think there's a really good, there's a lot to be said for learning through doing projects. Now, you don't want to take on something too ambitious because it really does create the problem where you're probably not going to finish. And if you are not familiar with any computer science concepts, you're probably going to, I should maybe just say programming concepts, because, I don't think you're going to need to worry about like big O notation or anything like that. Although there are a couple things that I'll maybe highlight about the way this is set up. I noticed that NumPy came up, so there's something about overflows in here, which might be an interesting anecdote to share. But yeah, there are actually some resources that you can check out online. The biggest thing that I say, though, at work, my old job, I used to have a reputation for being pretty okay. My coworkers would say pretty good. I would say I'm pretty okay. with Python. And the biggest thing is that a lot of people would ask, well, what's the best way to learn Python? Or can you recommend like a book or something like that? And I can recommend many. But the one thing that always surprised me was that people did not actually check out the Python tutorial. So in fact, I think if you just go to the beginner's guide, it's a little different from what I was thinking. I definitely like this book, Automate the Boring Stuff with Python. I haven't tried these ones, but presumably this one would be interesting. Actually, it's also by Al Swigart, so if I liked Automate the Boring Stuff, probably this is a good one. But what I was really looking for was the documentation. And I'll be the first to admit, reading documentation after I know some of these concepts tends to be a little bit easier. Hang on. Did they change this, or am I just losing my mind? In any case, I actually don't necessarily think the docs are all that bad of a place to look. So you have the interpreter. There are going to be some differences in terms of how this works in terms of the tutorial versus opening up a Python interpreter and running around with this stuff here. But if you want to learn some of the basic concepts that you'll need, all of these, okay, ignore this. Let's just do back. But, looking at all of this, the control flow is something that you'll probably find helpful. The fact that this may use NumPy is maybe a little bit of a concern, just because that behaves differently from Python. But I think you actually have a fighting chance if you just read and understand this stuff here. And then if you want to get better at Python, there's a really good book called Fluent Python, which really goes into the details of the language. Now, the problem is that I actually read it cover to cover. It's a big book. But it was a while ago, and they've released a new edition, so I forgot most of it. But there's lots of resources available to learn Python, and honestly, I actually do think this is not the worst way to start. I think some of the other tutorials might do a better job of introducing concepts at certain times in a better way. But my biggest thing is you probably don't need to spend any money to learn Python. And I don't know if people do watch this and say, okay, well, I do want to learn Python. I really don't know where to start. Maybe I can try and answer in a comment. So to do this, anyways, what I really wanted to stress here was that I can't say what the contents of this tutorial are going to be. So I'm going to take this tutorial at its word and say that it's too tough to learn Python from scratch. But on the other hand, I think if you understand a couple of programming concepts already, or maybe you've tried to learn Python before and you maybe didn't see it all the way through, but you have at least sort of the beginnings of an understanding, see how far you can get in this. And then maybe, if nothing else, it'll tell you where you start having some difficulty, and then that can guide you towards finding your other resources. So installation. To do this tutorial, you'll need Python version 3.7 or higher. The latest version of Python is recommended, currently 3.8 as of June 2020. I believe we're on to 3.12 now. We can download Python here. Now, I've actually, because I do a lot of work with data, I have actually using, it's not fully the Anaconda distribution, but basically I'm going to be using a package manager called Conda to do all of this. You'll also want to install the latest version of the tcod library, which is what this tutorial is based on. Now, I looked this up ahead of time, and this might actually get kind of interesting for me. So what I'm going to do here, this is actually going to be the first part where I sort of, this is kind of where I'm going to diverge a bit from the tutorial. So what I'm going to do here, I mean, it does say, it does talk about a virtual environment here. So additionally, if you're going to use a virtual environment, you may want to take the time to set up a requirements.txt file. This will allow you to track your project dependencies if you add any in the future and more easily install them if you need to. For example, if you pull from a remote Git repository. You can set up your requirements.txt file in the same directory that you plan on working on for the project. Create the requirements.txt and put the following in: tcod 11.13, numpy 1.18. Obviously, that may be different from the that may be different for another for where we are right now. Once that's done with your virtual environment activated, type the following command: pip install our requirements.txt. This should install the tcod library along with its dependency numpy. Depending on your computer, you may also need to install SDL2. So this is sort of a library that will draw things onto the screen. And I suspect with Linux, I'm going to need to install that. So check the instructions for installing it based on your operating system. For example, Ubuntu can install it with the following command: sudo apt-get install libsdl2-dev. So that's a lot of talking. Let's actually get on to the fun stuff. So the first thing I'm going to do is create this virtual environment. Oops. Well, that's fine. We'll create a virtual environment in Conda. I don't need to be specifically in here, but it's just nicer. So I'm going to create roguelike tutorial. So we're going to try Python 3.12. I might need to change that down. And then it wants numpy, and I'm actually going to see if tcod shows up. I'm guessing it won't, but you never know. So here it's just sort of phoning home to see whether or not it can find these things. Yeah, okay, no surprise there. Okay, so these are installing all of it. We're up to numpy 2. Now that probably is going to cause a little bit of trouble because I believe there were potentially some breaking changes introduced in numpy 2, but we'll run ahead. Part of this is actually when I first tried to learn programming, this was roughly around the time that MOOCs were becoming a thing. Like, they weren't fully formed. There were a few different things that people were trying, different universities were trying. And what I tended to notice was that there'd usually be like a course that was maybe going to teach you Java or something like that. And they would give you a library that made things easy, a little bit like what tcod's going to do. But the problem is they would never be maintained. And so I'd sort of get going and, I'd struggle because I'm learning with something. And then, you make a little bit more progress and it's like, okay, I think I'm kind of understanding where this is all going. And then, yet again, you find, okay, I'm having another problem and I can't seem to get past this one. And it turns out after all that work, it's because, the version of Java that you're using is, several versions higher, and this library just isn't compatible again. And there's no possible way that you ever could have got this thing working. So one of the things that I kind of want to do is, again, one of the advantages of recording this, even though obviously I have a tendency to ramble, one of the things that would be nice is to actually show the process of, figuring out how this stuff works, how can I overcome some of these challenges. Now, again, I was already trying to do something weird, and Conda, I think, keeps track of what pip does as well. So we'll do activate. Okay. Oop. I don't think that's right. I think I know what happened. Oop. Yeah. I tried to put a different shell on, which, never mind, doesn't matter. Well, I'm going to deal with that later. Oh, that's a shame I capitalized it. Okay. Conda activate. All right, there we go. So, pip, what did it want? Let's do. Okay, that's pretty encouraging. It looks like this ran. So I think what I'm going to try and do here is I'm going to avoid. Now it's possible that the SDL and all of that stuff is already working. I guess maybe I will make a requirements.txt. So we'll do that in. So does it say what version we had? 16.2.3. Okay. Any text editor can work for writing Python. You could even use Notepad if you really wanted to. Personally, I'm a fan of PyCharm and Visual Studio Code. Whatever you choose, I strongly recommend something that can help catch Python syntax errors at the very least. I've been working with Python for over 5 years, and I still make these types of mistakes all the time. So on that note, I'll talk a little bit about the extensions that I have in here. It's not as scary as all that. So all this Jupyter stuff, you don't need to worry about that. I do have the Python sign up. The only thing that I'm doing differently here is rough, which is it does still have Pylance on it, but this one I've noticed is really fast and it has a lot of errors that it catches. So this is one thing that I've added into Visual Studio Code, and it's just a nice way of catching errors, hopefully a little faster than the existing material. I think it also helps sort out your indentation and things like that, but we should start seeing those when the problems come up down below. Okay, making sure that Python works. To verify that your installation of both Python 3 and tcod are working, create a new file in whatever directory you plan on using for the tutorial called main.py and enter the following text into it. Now, one of the things that I'm going to do here is I'm going to make sure that we don't just copy and paste. There is actually some value in having your hands on the keyboard and typing things out and, having that experience of seeing if things work out. So for instance, I'm not used to putting the, user bin env Python 3. I kind of understand that stuff is important, but it just doesn't come up in my own case where I'm usually working in Jupyter notebooks all the time. That's still not an excuse for not knowing this stuff, but it's just, I'll just be honest in terms of where I'm at. So you can already see here, right? Undefined name imp. So actually I probably don't need to have both, but import tcod, I guess I can't, yeah. Tcod def main print hello world. I believe this has its origins in a book by Brian Kernahan and Dennis Ritchie called The C Programming Language. It's actually a really interesting one to read because C was considered to be I guess a high-level language at that time, and they sort of spend some time talking about what's being accomplished by doing all of these different things. And I don't know, I really appreciated that example, and it's probably included now. It's a thing that people include now just because it's a tradition, I guess. But I don't know. I think there's something kind of neat about looking into the origins of some of those kinds of stories. Okay, so here we've got the program as written. You'll notice here that rough and Pylance, there's that yellow line that we see inside of the code here. It's basically complaining that, look, you didn't really use tcod here, which is absolutely fair, But this is what the tutorial told us to do. So run the file in your terminal or alternatively in your editor if possible. So one thing I'm kind of interested in here is if I just run without debugging. I actually don't know what happens if I run with a debugger. I'm curious to see what this does. Could not find debug by PyPath. Okay, so yes. Don't I already have... I think I just messed this up. Okay, let's see what we've got here. Good Lord. I've done something I didn't want to do. So the problem is I'm just trying to find how I can delete that environment. But here's what I'm going to do. Let's start by saying, I was hoping to have this be a little bit more simple, but just as well that I'm learning this stuff now. So select. Okay, how about selecting one though? So Control-Shift-P. Okay, that's what I should have done. So before I do this, I want to see if I can get rid of that environment. The only thing that weirds me out here is that it's kind of got a blank name. So So yeah, this is the problem, is I don't know what to call this. So if I just do conda remove, how much you want to bet that didn't copy? Okay. So, so I don't waste too much time on this. Actually, I'm wondering... That was easy. All right. So sorry about that digression there. But so if it's unclear in terms of what I was doing, so basically I used a default option inside of VS Code, which probably wasn't the smartest thing for me to do because I did specifically make an environment in which I wanted to have these, I wanted to have tcod and numpy available. So instead of looking up how to activate a Python environment, I used that default option, said, okay, well, it was created inside here, didn't have a name. So I thought, okay, well, what happens if I just delete the directory? And in this case, it wasn't in the list of environments anymore. Now, again, if you're not using Conda, if you're using something like venv or something like that, you're probably not going to have to run into that problem. But essentially here, all that I was doing was taking advantage of the console to remove the folder. It is basically the same as just putting something into the trash. The -r was just because it was a folder there. So anyways, sorry for the diversion. So I'm going to leave this aside. Let's try running this again. I haven't the foggiest idea. And more stuff I don't want. That's interesting. Okay. So, what happens if I just do a good old-fashioned terminal? Cool, that ran. So that's kind of interesting that when I try to run in, when I try to run in VS Code, it doesn't like doing this. But if I just run it from a console, it does. So I'm going to remember that for the future. So again, it might be that we get hit by something later in terms of Python not working. But for now, I'm going to settle for this one. For this tutorial, we'll need an image file. The default one is provided below. Right-click on the image to save it in the same directory. So we've just done that here. If it's not displaying for some reason, it's also available here. About this site, code snippets in this website are presented in a way that tries to convey exactly what the user should be adding to a file at what time. When a user is expected to create a file from scratch and enter code into it, it will be represented with standard Python code highlighting like so. Class fighter, def init, self HP, defense power, self.max HP equals HP, self.HP equals HP, self.defense equals defense, and self.power equals power. So I'm sure this will explain it along the time, but basically what this is trying to do here is it's defining a certain type of object. In this case, it's called a fighter, and a fighter can be defined as having health, defense, and power. Self is something that you always include inside of a definition like this in Python. That's just a Python thing, and this is where you would be reading the manual to sort of find out why that's the case. And essentially what it's saying here is when you get set up, I'm going to give you 3 parameters here, your HP, your defense, and power. This is the thing that you will provide it when you create it. And this init, as you might guess, is initializing it. So it's going to start you off with all of these values. You start off with HP, you start off with defense, and you start off with power. And you can maybe see a situation where you might want to do something a little bit different. Maybe you start off with, a wounded fighter or something like that. And you would either provide 2 different parameters so that you could determine what the actual starting HP was, or if you wanted it to be off by the same amount, what you could do in this initialization would be to subtract it by some number or some fractional value, whatever you happened to decide. Most of the time you will be editing a file and code that already exists. In such cases, the code will be displayed like this. So actually you can see here, this is already an example, right? They went from these parameters here and they added fighter none, AI none. So, and this is the entity class, so presumably that's higher than the fighter, but it starts off with this extra information. And then because you can kind of get an idea here, right, that they added the fighter and the AI. And so in this case here, all of these are the 2 additional parameters that were added. Clicking a button above the code section changes the style, not just for that code block, but the entire website. You can switch between these styles at any time. In the case of the example above, you would remove the old init definition, replacing it with a new one. Then you'll add the necessary lines at the bottom. Both styles convey the same idea. Probably should show. So I'm reasonably comfortable looking at things like this. So you'll notice, well, I suppose it depends on how familiar you are with these things, but this is a GitHub repository. So that was already set up. My Python installation was already there. I already had VS Code. I had a GitHub repository that'll be public, and I already had Rough installed. So those are some of the things that I'm coming in with prior to starting the video, but it's already taken me 40 minutes and I'm only 3/4 of the way through lesson 0. So I got to start somewhere. But yeah, so in terms of looking at the divs, in fact, we might be able to, there should be a way to see. There you go. This looks kind of familiar. This might look a little more exciting when we add new things. So clicking the button above, sorry, I think we already covered that. In the case of the example above, you would remove the old init definition, replacing it with a new one, and then you'd add the necessary lines at the bottom. Both styles convey the same idea. But what's the difference? The diff style shows the code as it might be when you're doing a get diff comparison, hence the name. It always shows pluses and minuses on the side to determine whether you should be adding or subtracting a line from a file. The original style shows the same thing, but it crosses out lines to remove and does not have pluses or minuses. The benefit of the diff style is that it doesn't rely on color to denote what to add, making it more accessible all around. The drawback is that it is impossible to accurately display the proper indentation in some instances. The pluses and minuses should take up one space, so in a code section like this one, be sure not to leave the space for the plus in your code. There should be no spaces before from. So we'll add that here. From input handlers import handle keys. Okay, so now this is interesting. So Pylant says that this is missing, whereas Rough says it's imported but unused. So I'm curious to see what changes here. The original style omits the plus and minus symbols and doesn't have the indentation issue, making it a bit easier to copy and paste with code sections. Which style you use is a matter of personal preference. The actual code of the tutorial remains the same. Be sure to check in with the Roguelike development subreddit for help. There is a link there to the Discord channel as well. Ready to go? Once you're set up and ready to go, you can proceed to part 1. Now, normally in each section, what I would do is I would commit the change to the repository, but I'm actually feeling a little uncertain. I guess one thing I could do here would be just to go back to the terminal and see whether or not this runs. Yeah, so there's no handlers here. So actually here we can do. It's not really the initial commit. Now, one thing I forgot to do here is actually stage the changes. So this isn't really this isn't good for a Git tutorial, but if you have not used Git before, the basic idea goes, you'll make some changes. It's a way of sort of keeping track of changes over time. So you're not doing, main.py _final _2 really final _revision, that sort of stuff. So the way that Git tends to work, it's intended to be distributed so that multiple people can work on a project at the same time and they don't need to phone back to the mothership. So what you do here is you stage changes. So this is sort of saying, okay, we're getting ready to say, these are the changes that matter. These are the things that are going to go into this commit. We'll say this is actually, it's not really the initial commit. So we'll just say that here, completed part 0. That's not really descriptive of what we did. That's a little bit better. So we've staged these. Now we'll hit commit. And one of the things that's worth remembering here, especially if you wind up collaborating with people, is that these changes right now exist on my computer. Now, sometimes it'll only ever live on your computer. In this case, because it's on GitHub, it's gonna have to go on the internet. If I were to take a look at my GitHub site right now, I would not see these changes. They are committed to my repository, but in this case here, I've not yet actually put all of these changes into that repository. So this can be, again, this is where the decentralized or the distributed version control can sometimes be a bit of a help. In this case here, you can sort of imagine a situation where, I don't know, somebody accidentally deleted something. You don't necessarily, maybe you even deleted the GitHub repository. Well, that's fine. You still have all your stuff on your computer at home. And so in principle, you'd be able to restore that. But of course, the drawback is if there were some changes that, if the version got deleted, had some changes that hadn't been stored anywhere else, then, you've lost those particular changes. So in this case here, there is you'll stage them, you'll commit them, and then finally we want to push them to the repository, which we'll do here with sync changes. Although we don't need to do that every single time we do them. In fact, what I'll probably do is I'll add commits where I think they are important, but I'm going to, and I'm not going to do anything like branching or anything along those lines, unless maybe I have, an idea that I want to sort of go down an interesting path with. But in this case here, I'll maybe just leave the sync for the end of the video or something like that. Your mileage may vary. You may not even, do this in Git. All right, part 1. This will be the last thing that we do for the video here. So part 1, drawing the @ symbol and moving it around. So the @ symbol is traditionally the main character in a rogue game. Actually, the funny thing is that I meant to say this in terms of my origins with the roguelike genre. One thing that I found really interesting of going down this rabbit hole of roguelike games was I only realized after the fact I'd played a game called Sword of the Stars, The Pit, and that was a very traditional kind of roguelike game. I just didn't appreciate what rogue really was. I'd heard the name, but it was just one of these things, right, where it's all ASCII text on the screen. So I'm like, well, that doesn't seem very interesting. I'm not going to bother with it. So in this case here, I've since learned that the @ symbol was sort of the representation of the hero in terms of these games. So that's why we start here. And then if you go to the RoguelikeDev, right, that's right there. We might change this around later, but I'm not an artist, so I'm going to stick with the existing art. Welcome to part 1 of this tutorial. This series will help you create your very first roguelike game written in Python. This tutorial is largely based off of one found on Rogue Basin. Many of the design decisions were mainly to keep this tutorial in lockstep with that one, at least in terms of chapter composition and general direction. This tutorial would not have been possible without the guidance of those who wrote that tutorial, along with all the wonderful contributions to TCOD and Python TCOD over the years. This part assumes that you've either checked part 0 and are already set up and ready to go. If not, be sure to check that page and make sure that you've got Python and TCOD installed and a file called main.py created in the directory that you want to work in. Assuming you've done all that, let's get started. Modify or create, if you haven't already, the file main.py to look like this. We're already set up there. You can run the program like any other Python program, but for those who are brand new, you do that by typing python main.py in the terminal. If you have both Python 2 and 3 installed on your machine, you may have to use Python 3 main.py to run it. It depends on your default Python and whether you are using a virtual environment or not. Alternatively, because of the first line user bin and Python, you can run the program by typing .mainpy, assuming that you've either activated your virtual environment or installed TCOD on your base Python installation. This line is called a shebang. Okay, not the most exciting program in the world, I admit. We've already got our first major difference from the other tutorial, namely this funky looking thing here. This is something that's very easy to overlook when writing Python, incidentally. I very rarely put this in, but I also very rarely have situations where I need them. So what does this do? Basically, we are saying that we are only going to run the main function when we explicitly run the script using python main.py. It's not super important that you understand this now, but if you want a more detailed explanation, this answer on Stack Overflow gives a pretty good overview. So I'm going to assume that this explains it better than me, but the main idea here is that if we run this as, well, as it says, if we run this as a main program, it goes into main, and right now main prints hello world. There can be situations where this might run when you're not running it as the main program. And at that point, you don't want everything to run. So like maybe you do a print statement and you've got a very personal letter to your beloved, right? In that case, you only want that when the beloved's running it in the main program, and you don't want anybody else seeing that. So you don't do an open source project or so. This is such a stupid example. But yeah, basically the idea here is that we're saying, okay, we've got a function. We only want this function to run when we're running this as sort of a main program, which is exactly what this thing is doing here. These two underscores, I believe, are called dunder. Double under, I guess. Anyways. Confirm that the above program runs. If not, there's probably an issue with your TCOD setup. Once that's done, we can move to bigger and better things. The first major step to creating any roguelike is getting an @ character on the screen and moving. So let's get started with that. Modify main.py to look like this. All right. So first thing we're going to do, it's defining screen width and height. Now, I think the 80 width actually has its origins in punch cards. So I think it used to be that there could only be like 80 punches. I've seen versions which say 79, so there might have been something along the side as well. But in any case, this doesn't fully fit the 80 if we close this down. So you can get a bit of an idea. It actually keeps track of this stuff down below here, but you can do, I don't know if there's a faster way of doing that. I know in Emacs you can put you can just tell it to repeat the same thing, but that's about as wide as you can get. So if we open the directory, we lose the real estate. Not that important. So as you can see, it's yelling at us because the screen height is never used. We'll change that momentarily. Tile set. tcod tile set. Load tile sheet. So this is the advantage of using something like Visual Studio Code. So if it's not clear why these are automatically filling in, I'm just using tab when I see the function that I'm looking for. And in this case, deja vu, I don't think it's going to take, 10 by 10 gstc.png. So in this case here, we already know here from tcod tile set. So in this case, Rough should stop yelling at us for not using tcod. We're using the tile set that we were given as part of this tutorial. We know that we're pulling this from tcod because we're basically taking the tcod phone book and calling tile set. And then from tile set, we're using the load tile set method. And it actually tells us, this is another nice feature of Visual Studio Code. It'll actually tell you what these different parameters do. So in this case, it's the number of columns, it looks like. Yeah, columns and rows, the shape of the tile sets. Tiles are assumed to take up the entire space of the image. And then this last argument, so int rows character map, ooh, iterable. Right, so we're pulling something from tcod tileset charmap tcod. So generators will be sliced, so itertools.count can be used, which will give all the tiles the same code point as their index, but this will not map it, to proper Unicode. If none is used, then no tiles will be mapped. You will need to use tileset remap to assign code points to the tileset. So the best thing that I can say for this is the good people at TCOD have given us something so that we don't need to think about this. I'm curious if it'll explain it, but in this case here, we're just taking this as given because somebody already gave us the tile set here. Here we go. This layout is used by older libtcod fonts in Unicode. This layout is non-standard and it's not recommended to make a font for it, but you might need it to load an existing font made for libtcod. Okay, so presumably this is the inheritance from the old tutorial. This character map is in Unicode, so old code using the non-Unicode tcod car constants will need to be updated. See deprecated tcod layout for table of glyphs used in this character map. And then we close this with the parenthesis. So with tcod context new terminal. So I will more commonly use with when I'm opening a file. And this is just a nice little convention in Python which says if something goes wrong in the middle, you don't need to worry about explicitly closing anything like that. Basically, you know, we've got this thing and a bunch of stuff is going to happen inside of it, and we will take care of sort of setting it up and tearing it down as long as you do it inside of with. I think that's basically what's going on. So here we use the constant that we defined before. I know there's a convention for some people that says because this is a constant, you should do this in all capital letters. I'm not really sure it's that important, but I think it's maybe just worth mentioning. Okay. That's interesting that they're making us do a comma at the end. I don't normally see that. I don't think it hurts anything. I'm curious if not having it would cause a problem though. Okay, so this is the other, we're letting the other shoe drop. So essentially we're making this terminal here. We're saying we're going to call this context. So this is referencing to a terminal. I think this is basically going to be the place where we play the game. And in this case, we say root console. So it's the left-hand side of the equal sign. So we are defining something here. Console. Now that's interesting that I'm going to keep the capitalization. In fact, oh, I put a dot in. That might explain why this went weird here. I'm intrigued by the fact it didn't sort of populate something, so I don't know what this does. So while true, this is traditionally something that you'll do to basically just say run forever. So while loops, so there can be some situations where you'd say while the timer is less than a certain amount, or while there's still something in this collection, do the following things. While true will always be true, and essentially what we need is something to say, okay, when it's, when we're done, there's going to be some other intervention that stops the game from running. And from what I understand, most, if not all, games have some variation of this running in the background because they're interactive things. So we'll actually get to the interruption probably within this code block, if I look ahead a little bit. So we've got root console, which we defined above, print x equals 1, y equals 1, string equals ampersand. Is that ampersand? I think it is. So it's a bit tricky here. I'm not 100% sure how this stuff lines it up. I'm going to make a guess that this will appear in the top left-hand corner, but already you're sort of getting an idea of how because all of this stuff has been given to us, we don't necessarily know how tcod thinks about these things. So when they start, if we were plotting this on graph paper, you might think that for the y-axis, 0 starts here, and the x-axis, we sort of move left to right. And of course, that's usually because in graphs, if we're taking that plane, if we were to shift the sheet of paper, and we'd see sort of the axis here, and then this is the origin, right? We want to start in the bottom left, and that just gives us options in terms of where we're moving. Whereas in this case here, if we were to say, okay, well, let's count the number of characters, sort of a little bit like what VS Code is doing here. Well, this is 1, 1, and then we keep moving to the right so that the x value keeps going up by 1, and then the y value goes up as we move down. That's obviously quite different from how we think when we traditionally think about plotting things on a graph. And so actually, from my understanding, there is a difference between the Unreal Engine and sort of Unity and Blender and all of those things in terms of where they define the different axes. And so even when there are conventions, sometimes the decisions that people make when they're figuring things out can sometimes have these long-term consequences, right? Because at what point do you tell all the Unreal developers, hey guys, you need to relearn this really fundamental thing of your tools? So presumably they just stick with the old way. Anyways, I don't know if that, obviously I am an outsider, so I could be wrong on some of these examples, but I always think this sort of stuff is kind of interesting. Anyways, we'll find out too. It's just kind of a nice way. Remember I said earlier how it's not always good to just copy and paste this stuff. You try to make an effort to say, okay, what is this program doing? Why am I taking these steps? And in this case here, this is just a nice little opportunity for me to say, it's like, okay, so what I think is happening here is we're putting the ampersand sign in the top left-hand corner. That's what this print function is doing here. And I know that because the root console is calling this item here console. Console has the screen width, screen height, so on and so forth. And it exists within this context of a new terminal. And in this case here, I'm saying we orient ourselves by considering the top left-hand corner as sort of being the origin, as opposed to the bottom left, as we would if we were plotting something out on graph paper. Could be wrong on that, but being able to just sort of say, here's what I think this function is doing, is a nice little opportunity for us to see whether or not we understand how this program's working. Because of course, we don't just want to make the tutorial, or we don't want to make the game that this tutorial is giving us. We want to learn the tools to allow us to make our own things and to tell our own stories, or to create our own experiences. So context. So again, we're calling this thing here the new terminal. Present root console. So if I had a guess, this is saying, this is the thing I want you to do. Now display it in the context. So this is saying, it's like, okay, make this thing happen. Now show the world. Again, I don't know. I'm just taking this from sort of the verb present. And then finally for event in tcod event wait. By the way, one thing I can do, so if we do context present, nope, didn't automatically fill that in for us. So I wonder if I were to do, nope. Block until events exist, and then return an event iterator. It's useful for simple games with little or no animations. The following example sleeps whenever events are queued. So this is basically just processing all the different things that happen. If event type equals quit, raise. So I believe this is what's known as an exception. And in this case, it's basically saying, I mean, effectively, it's kind of crashing out of the game. But that is definitely a very Python way of handling these things. So remember how I said that this is going to run forever until it has some sort of an intervention? Well, that's this moment here. Raise system exit. I'm sure if nope, apparently not. But yeah, basically, if we get a quit signal, which presumably we're going to have to define somewhere else, it's going to say, okay, get me the hell out of here. And I mean, I don't think it's terrible that it crashes out because we just want to close the game. So as long as the window closes, we're happy. run main.py, and you should see an @ symbol on the screen. So let's do that now. And I'm actually going to try that trick where it said, if we run main, main.py. So it said that the shebang should allow me to run this. I'm actually slightly curious if I misunderstood. Oh, / okay. Permission denied. All right, let's just do this the old-fashioned way. Interesting. Okay, so our first error. Module tcod console has no attribute new terminal. Right, well, that's not console, that's context. That's an easy fix. And as predicted, a little @ sign in the top left-hand corner. And I also notice I said yes, another roguelike tutorial. So we can kind of consider that the hello world of representing images on the screen. There's a lot going on here, so let's break it down line by line. Screen width equals 80, screen height equals 50. This is simple enough. We're defining some variables for the screen size. Eventually, we'll want to load these values into the... Actually, you know what? I wanted to just double check here. So I think if I do Control-Shift-L... Right, so if I wanted to follow that convention of capitalizing, we have the tools to be able to change that, all instances of that. I'm not going to change it here. I'm going to stick to the tutorial. But all right, so defining some variables for the screen size. Eventually, we'll load these values from a JSON file rather than hard coding them into the source, but we won't worry about that until we have some more variables like this. Or like this. So tile set, here we're telling tcod which font to use. Deja Vu 10x10 GSTC PNG bit is the actual file we're reading from. This should exist in the project folder. We downloaded that in the previous step. So with context new terminal, this is of course the one that we had the bug with. This is the part that actually creates the screen. We're giving the screen width and screen height values from before, 80 and 50 respectively, along with a tile. Change this if you've already got your game's name figured out. Tileset uses the tileset we defined earlier, and vsync will enable or disable vsync, which shouldn't matter too much in our case. So the reason why, I mean, knowing this here, maybe I don't need to give the commentary as I'm going through it. But again, this is the difference between just passively entering in all of the different variables that we are encountering as opposed to being a little bit more engaged with the tutorial. This is the nice little opportunity for me to say, okay, did I understand what this was doing? And of course, it's also worth saying, right, if I didn't understand some of these things, it might be an idea to sort of open up the manual to take a look at the documentation and see what all of these different things are doing, right? So I can maybe try and find out what exactly this care map tcod is doing. But the thing is that, you know, we can write all of these tools, you know, top to bottom or bottom up, I guess. But one of the reasons why we like computers and why we like things like open source and, you know, tutorials like this and libraries like tcod is the fact that they allow us to do that much more, right? Rather than everybody taking the time to write their own set of tools to be able to realize, you know, the little ampersand in the top left, we can take advantage of people who've already solved that problem for us and have done so in a way that at least the subset of users who are using it find it a very natural and sensible way of thinking of that particular problem. And so in this case here, you know, I want to have an understanding in terms of how this works, because eventually I'm going to want to take these tools and make my own things with them. But I don't want to become so committed to this idea of, you know, just this full comprehensive understanding of the entire library before I finished part one, because at that point I'm going to become a student of tcod as opposed to, you know, developer of a roguelike. So, but these are also, to me, these are the moments where in the back of my head, I start thinking of something saying, it's like, okay, so maybe in 2025, when the roguelike dev community decides to do another tutorial or another run through the tutorial, and I want to be like those people who are saying, I'm doing one in Common Lisp, or I'm going to do one in bfunge or something. This is I don't think you can use TCOD if you do it in an esoteric language, but this is one of these opportunities where I get to say, oh, okay, this was one thing that I didn't understand that well, or maybe this is going to be something that I want to change. And it seems like there are some functions. So here's an example. I'm just going to throw this out there. Could I make it so that there's a spell which expands the playing field? Well, right now, I'm going to guess no, because if I've got this context right now. Actually, then again, I guess if there was an option for me to say something like, context dot, it would be, doesn't really say what okay, well, if we did tile set, okay, well, there we go. It's got change tile set. So actually, there's one, right? You've got a spell that transforms everything. Maybe you have a Wizard of Oz moment where you go from a black and white farm to a colorful area, right? That's an option you have in there. But is there a way that you could manipulate it so that your environment changes? Clearly here you define it and you're sort of within the context, but is there a way of taking the context? I'm actually pretty sure if we did context and then maybe, yeah, here we go. Okay, so it'd be rows. So okay, I don't have an obvious I don't have an obvious candidate for altering the width and height, but I already have a couple of places I would look, right? I'd want this interaction between the context or the terminal and the console and say, okay, do I have some sort of some indication in terms of how I might change that? And again, maybe the idea of changing the size of the playing field isn't all that interesting, right? I just kind of wanted to take something out there. But this is an example of where I'd sort of say, okay, in the back of my head, if this is something that I'm thinking of doing, here's an opportunity for me to look a little bit deeper into how this works and move in. And of course, that would also be a point too, where I say, I really want to make a game that blows people's minds by changing the size of the playing field, which I'm sure would be wonderful on a television. That might be a point where we say, okay, well, you know what? This is a case maybe where the library is getting in the way. So how badly do I want this thing, right? Am I willing to move from a particular set of tools that I was taking advantage of? Do I want to make my own custom ones to be able to realize this thing? Again, I'm not trying to suggest that the size of the terminal is all that big of a deal, but I wanted to give an example in terms of how we might want to try and, put a stamp of authorship on what we're doing and why we might want to look into these things a little bit more deeply. Okay. Root console, TCOD console, screen width, screen height, order F. This creates our console, which is what we'll be drawing to. We also set this console's width and height to the same as our new terminal. The order argument affects the order of our x and y variables in NumPy, an underlying library that TCOD uses. By default, NumPy accesses 2D arrays in a YX order, which is fairly unintuitive. By setting order F, I think that's Fortran that stands for, actually. We can change this to be XY instead. This will make more sense once we start drawing the map. That's actually good to know that's what they're doing. Okay, well, true, this is what's called our game loop. Basically, this is a loop that won't ever end until we close the screen. Every game has some sort of game loop or another. Root console print x1, y1, string the ampersand. This time, actually, let me make sure that the ampersand is what I think. Yes, okay, my bad. Ampersand is the at and not. Oh, it is called the at sign. My bad. It felt weird calling it ampersand, so should have followed that doubt. Okay, we are going to call it at. This line is what tells the program to actually put the at symbol on the screen in the proper place. We're telling it the root console we created to print the at symbol and at the given XY coordinates. Try changing the X and Y values to see what happens if you're so inclined. So here's an example. How would I get this into the middle? Well, basically something like this, I would assume. Right, now we've got an indication in terms of we understand. Oop, didn't mean to do that. This is just an example in terms of where we say, it's not just that we said, okay, I think this is going to move a little bit to the left or right. I specifically said this is going to be in the middle, and we got it in the middle. One of those examples where you can sort of say, I've demonstrated that I understand what this thing is doing. Although it might have been a little bit more creative. Let's say here, let's move this 10. So I think this is going to be moving 10. Well, actually, no, I guess I already know it's already moving 10 to the right based on what happened inside there. But, all right. Context present root console. Without this line, nothing would actually print out on the screen. This is because context present is what actually updates the screen with what we've told it to display so far. Okay, sounds consistent with what we've been, what we were expecting. And for event and tcod event wait, if event type equals quit, raise system exit. This part gives us a way to gracefully exit, i.e. not crashing. Okay, so I shouldn't have said not crashing. Again, I thought this was an exception, which I guess would leave the game. But anyways, a way to gracefully exit the program by hitting the X button in the console's window. The line for event in tcod event wait will wait for some sort of input from the user, mouse clicks, keyboard strokes, etc., and loop through each event that happened. System exit tells Python to quit the current running program. All right, our at symbol is successfully displayed on the screen, but we can't rest just yet. We still need to get it moving around. We need to keep track of the player's position at all times. Since this is a 2D game, we can express this in two data points, the X and Y coordinates. Let's create two variables, player X and player Y, to keep track of this. So this would be an example here where, I sort of said capital letters would be something where you might put constants. Because it's a player position, we would obviously not want to put uppercase for that, because that would imply that the player isn't moving. So player X, player Y, so what this is saying here is take our screen width, divide it by 2, and because it's possible that this is an odd number, so for instance, if we said maximum lines in a Python program, this would create a problem, because in the end we want to represent this on a row or a column, and you don't have a half row or a half column, at least as far as we've been talking about this so far. So int is forcing this into an integer. I think there's also, if you do a double slash like this, you'll get something that forces an integer, but in this case here, it's running through. Now, does it go up or down? I actually don't know off the top of my head. I probably should remember that, but in any case, this is converted to an integer. I don't think we need to worry about it in this case, because we've got 80 and 50, so this should be 40 and 50. And actually, I think they've decided that they want to start the player in the middle of the the map too. So, okay. Note the ellipses denote omitted parts of the code. I'll include lines around the code to be inserted so that you'll know exactly where to put new pieces of code, but I won't be showing the entire file every time. The green lines denote code that you should be adding. We're placing the player right in the middle of the screen. That's what what's the int function though? Well, Python 3 doesn't automatically truncate division like Python 2 does, so we have to cast the division result, a float, to an integer. If we don't, tcod will give an error. Oh, that's right. Actually, yes. So I think even we can actually test this. So if I go Python, So if I take 4 divided by 2, if this gives a 2.0, yep. So 4/2, 5/2 gives us 2. Okay, so it's even though 2.5 would normally round up to 3, in this case it just chops off the second half. So yeah, we could have got the same result by doing a double slash division instead, but we don't need to get fancy. Oh, it says it right here. And it's been pointed out you could divide with double slash instead of slash to achieve the effect. That's true, except in cases where, for whatever reason, one of the numbers given is a decimal. Oh, interesting point. For example, screen width 2.0 will give an error. Let's see what happens there. So let's do 2 divided by 2.0. So it returns a float as a result. Interesting. That shouldn't happen in this case, but wrapping the function in gives us certainty that this won't ever happen. I learned something about Python today. We also have to modify the command to put the @ symbol to use these new coordinates, so presumably we'll change that in print. Yep. Run the code now and you should see the @ in the center of the screen, which isn't news to us, but still good to see. So how do we actually capture the user's input? Tcod makes this pretty easy. In fact, we're already doing it. This line takes care of it for us. So rather than just waiting for a quit, we can presumably look for left or right or up or down. So it gets the events, which we can then process. Events range from mouse movements to keyboard strokes. Let's start by getting some basic keyboard commands and processing them. And based on what we get, we'll move our little @ symbol around. We could identify which key is being pressed right here in main.py, but this is a good opportunity to break our project up a little bit. Sooner or later, we're going to have quite a few potential keyboard commands, so putting them all in main.py would make the file longer than it needs to be. Maybe we should import what we need into main.py rather than writing it all here. Than writing it all there. To handle keyboard inputs and the actions associated with them, let's actually create 2 new files. One will hold the different types of actions our rogue can perform, and the other will bridge the gap between the keys we press and those actions. Create 2 new Python files in your project's directory, one called inputhandlers.py and the other called actions.py. Let's fill out actions.py first. So we'll make both of those now. Just doing both of those now because it's a little cramped. Oh, we were doing actions. Okay. Class. Remember we said that you always start with self, so dx, so presumably that's the change in x position. dy int. This is also type hinting, so it says that we're going to have integers for our delta x and delta y. I mean, makes sense. Super. So that's in reference to the action, I think. Okay, so a confession to make. When I first learned, at school, I just did economics, but I did make sure to take a couple of computer science courses because as I mentioned before, I had struggled to do this online. But we first learned a language called Scheme, which is sort of a variant of a very old programming language called Lisp. And I sort of bear the stamp of my origins here in the sense that I still tend to think in that mode rather than the rest of the world, which is full of objects. So it is actually quite unnatural for me to build classes for things, and I understand that they are very helpful. In fact, I do know enough Python to know that if I want something that looks like an interface in another programming language, there is in fact something called abstract base classes, but I am still going to admit it is actually very unnatural for me to think this way. But essentially what we have here is we are defining sort of these these objects. I actually always, for me, because I like philosophy, I've always made sense of object-oriented programming by thinking of Plato and the forms, right? So you have these different instantiations of these, these higher concepts. And so in this case here, we've defined a class called action, and then action can be, this is a more general and abstract idea, and a specific type of action, something below action, would be an escape action. We're adding a little bit more description. It's something different from movement action. And in the case of movement action, this is saying it's inheriting from action here. For movement action, we've specifically said that we want some change in movement. So I don't think anybody who doesn't understand what classes are is going to have a better understanding of what classes are. But this is one thing I'm kind of looking forward to as part of this tutorial, which is to see how people choose what becomes a class and how they sort of navigate this stuff. Okay. We define 3 classes: action, escape action, and movement and movement action. Escape action and movement action are subclasses of action. Also, they get passes here. This is basically to stop the program from complaining, but they don't do anything at the moment. So what's the plan for these classes? Basically, whenever we have an action, we'll use one of these subclasses of action to describe it. We'll be able to detect which subclass we're using and respond accordingly. In this case, escape action will be when we hit the escape key to exit the game, and movement action will be used to describe our player moving around. There might be instances where we need to know more than just the type of action, like the case of movement action. There, we need to know not only that we're trying to move, but in which direction. Therefore, we can pass the dx and dy arguments to movement action, which will tell us where the player is trying to move to. Other action subclasses might contain additional data as well, and others might just be subclasses with nothing else in them, like escape action. That's all we need to do in actions.py right now. Let's fill out our input handlers.py, which will use the action class and the subclasses we just created. So I'm noticing again here, typing import optional. I should actually just mention here, this bit is not necessary for Python. I have been starting to warm to it though. This is just a nice little way of communicating to both the program and also to other programmers what you're expecting. So Python uses a convention I believe is called duck typing. So if it walks like a duck and quacks like a duck, it's a duck. And so very often you'll get into certain situations where, actually here's a decent enough example. So, right, so 1 plus 1, we would expect that that's 2. 1 plus 0 is 0. So what happens if we get true plus true? Well, obviously that's 2, and then true plus false is 1, right? In this case here, this comes as a result of Boolean values being basically being numbers down below. So in this case here, Python's able to translate that into a number. I actually think this is also true for something like C as well. Although I don't believe you could do this in Excel, now that I think of it. I don't think Excel actually treats true and false as numerical values. But basically the idea here, right, is that, do 2 wrongs make a right? 2 wrongs make a number in this case. So this might be surprising if what you are expecting as a result is an integer. But in my experience, this isn't a big deal, but I also tend to just be writing sort of almost Kleenex programs that I use once and throw away, right? In the end, I'm just trying to take some data that I have and turn that into some sort of an insight. And then that insight will go into sort of something that I write in prose for somebody else to read. So one of the opportunities here, in the case of making a game, this is something structured. This is something that somebody else is going to be expected to run on their computer. And more importantly, if I get very ambitious with this game, maybe I'm going to want other people to be working on it. And so the last thing that I want is somebody to take a look at, arguments that I'm giving to a function, and they'll see true and false. And because I haven't explicitly stated that it has to be an integer, they're going to be like, oh, well, these take Boolean values. Wait a minute, why is the screen width taking a Boolean? Does this mean that the screen does not have width if I give it false? Some of these are I mean, again, that's a very artificial example, but this is kind of something that I'm warming to, but isn't necessary. So the typing import optional is basically following in that spirit. So from typing import optional, import tcod event, and from actions import action, escape action, and movement action. So this is coming from this file here. You'll notice we don't have the main inside of this, and that's because we're importing these from this file as opposed to running it like main. All right, class and handler. So in this case here, we're defining a new class called event handler, but we're inheriting from event dispatch. And specifically, we're saying event dispatch. I think in this case, this is some kind of iterator, and it's an iterator of actions. So in this case, it's saying that give this stuff that we get from the actions module that we made. So we're defining a method here, ev quit, self event, tcod event quit, and we're saying we want, this is again talking about types, so you're going to give me a quit, and the end result is going to be an action. So method, parameters, result. And you'll notice it's basically our quit again. But we're putting this into a separate part to say we're handling things that players are giving us. This is players told us they don't want to play anymore, and so this is now part of input handlers. Presumably this is going to be removed when we get back to main.py. All right. So now we've got an event called keydown. That's really cool that a tab filled all of that. So let's make sure that that's right. Self event, didn't even need AI for that. Tcod event keydown. All right, so it says here an action or a none. We're going to change that to, I'm actually not quite sure what optional is. It's come from typing, but it's equivalent to union. Oh, that's interesting. So it's kind of trying to do this thing that was, that had the or none from before. So I think it's actually doing something equivalent. So return super ev keydown event. Well, we're not going to do that. What we're going to do here is action equals none. So the key is event.sim. So I think that's the symbol of the key that was put down. If key equals tcod. Now, I guess this might be where you could use something like a switch. I don't know if that's in Python or not, but we're just going to go through all of the ifs. Action equals movement action dx. ody equals -1. So makes sense, right? If this is 1, 1, if we want to move, if we push the up key, where do we want to go? Well, we want to go further up the screen. So -1 to the dy. Else if key equals event k down. So this might be that case. We'd say, well, what would the action be in that case? Well, it would definitely be a movement action. But what are we doing? Well, we'd just be doing the opposite of what the up was. And in this case, we would be incrementing dy by 1. So we're moving left now, so that's -1. Remembering 1, 1 is here, so we want to be moving off the screen if we're at 1, 1. Now, of course, with that in mind, if we don't put barriers on the game, we're hoping that TCOD has something that will stop us from going off the edge. We don't actually know what that action is. If we wanted to learn a little bit more before we test inside the game, that would be a case where we want to go and look at the documentation. I'm not worried about that yet, though, because we don't even have anything to actually connect this to player movement yet. Presumably at some point a player is going to get its own module here. That feels like the sort of thing you'd put into a class. Anyway. Presumably this is right. Oops. Key right. Yep. There is, incidentally, one option that I would have here is, actually, I'm just trying to think, could I do this? No, because it's a class. I was thinking if it was like a method of some kind, we could say, oh, well, we just give the default value 0, so we only need to define the x or y, but we couldn't do that in this case. Okay, else if they press escape, then they're going to want to do the escape action. This is just a comment, return action. Okay. Let's go over what we've added. From typing import optional, this is part of Python's type hinting system, which you don't have to include in your project. Optional denotes something that could be set to none. So yeah, that's what that was trying to do when it filled it in and it gave the or none. Effectively, that's what the result was here. So I think probably the thing I didn't understand about typing was when it says ev quit or ev key down, it's like, okay, give us an action, but we're not worried if we don't get an action. It's also possible that nothing happens. Import TCOD event. Well, we've used all of these events here. From actions, import action, escape action, movement action. These are all the things that we defined earlier. We're importing TCOD events so that we can use TCOD's event system. We don't need to import TCOD as we only need the contents of event. The next line imports the action class and its subclasses that we just created. Class event handler, TCOD event dispatch action. We're creating a class called event handler, which is a subclass of TCOD's event dispatch class. Event dispatch is a class that allows us to send an event to its proper method based on what type of event it is. Let's take a look at the methods that we're creating for event handler to see a few examples of this. ev quit, raise system exit. Here's an example of us using a method of event dispatch. ev quit is a method defined in event dispatch, which we're overriding in event handler. ev quit is called when we receive a quit event, which happens when we click the X in the window of the program. In that case, we want to quit the program, so we raise system exit to do so. On key down, the method will receive a key press events. Now again, we only have a subset of keys that we can press, right? I'm sure anybody who looks down at their keyboard will see more than an up, down, left, right, and escape button, which is why having a sort of a null result, the none here, is acceptable. This method will receive key press events and return either an action subclass or none if no valid key was pressed. Action optional equals none, key event.sym. I'm curious what this does. Action is a variable that will hold whatever subclass of action we end up assigning it to. If no valid key press is found, it will remain set to none. We'll return it either way. Key holds the actual key that we pressed. It doesn't contain any additional information about modifiers like Shift or Alt. It's just the actual key that was pressed. That's all that we need right now. Okay, so yeah, our guess was right. I mean, the definition here kind of gave it away, but from there, we go down a list of possible keys pressed. For example, if key equals TCOD event K up, do this. In this case, the user pressed the up arrow key, so we're creating a movement action. Notice that here, and in all other cases of movement action, we provide a dx and a dy. These describe which direction our character will move in. Else if escape, if the user pressed the escape key, we return escape action. We'll use this to exit the game for now. though in future, escape action can be used to do some things like exit menus. And then return action. Whether our action is assigned an action, subclass, or a none, we return it. Let's put our new actions and input handlers in main.py. Edit main.py like this. All right, so first of all, we need to import our new modules from actions, import escape action, movement action. We don't use event, we don't use the base action, so we don't bring that in. From input handlers, import event handler. So after we load the tile set, it wants us to give an event handler. And we just define that. So now we get rid of the quit. And instead we say action equals event handler dispatch event is none, continue. So that's basically saying it's like, okay, if they didn't press anything, we're saying if we didn't define action for this key press, just carry on. Sorry, I gotta sneeze. Excuse me. If is instance action movement action. So basically this is saying it's like, okay, so we were given, somebody pushed a button. If it's a movement action, if we take a look here, we have a bunch of different movement actions, but not an escape. So basically, if it's one of these 4 possible actions, then we're going to change the player position. If you've never encountered this before, this is the equivalent of writing player X is equal to action. So rather than having to define the variable again, you can just put the plus in front of it. I think there might actually be, I saw a video which talked about this, but I have no idea if it actually does anything. All right. This might also be interesting to look at. So what this is actually doing here when we've got an action, remembering that the action is this movement action. So essentially what it's doing here is it's saying, it's like, okay, take this movement action, take that self dx or that self dy. So in this case, these were defined in here. So essentially these are just sort of containers for the dx and dy. So where I was talking about where I wouldn't use classes, like in one case, what you could do is you could just put these in some other container and hand them back. The thing is that when you do this in classes, it's easier to say this is a movement action, right? Everybody can understand from the text what's going on here. Whereas if I just hand, some little tuple, right, put a couple of brackets around something and have, 1 and 0, and take the items out of that, may be less clear to people in terms of exactly what's going on. So like I said, this is an opportunity for me to learn a little bit about how people think about these kinds of problems and write effective programs using them. Okay. Elif is instance action escape action. So this is the one thing we haven't handled yet, and we want to quit the game. So raise system exit. And that's it for the new additions. Let's break down the new additions a bit. So we're importing escape action, movement action, and from actions and event handler from input handlers. This allows us to use the functions that we wrote in our main file, create a new event handler. It's an instance of our event handler class. We'll use that to receive events and process them. We send an event to our event handler's dispatch method, which sends the event. Did we write dispatch? Looks like that is inherited from event dispatch, which sends the event to its proper place. In this case, a keyboard event will be sent to the ev keydown method we wrote. The action returned from that method is assigned to our local action variable. So that's this thing right here. If the action is none, pretty straightforward. If action is none, then we skip over the rest of the loop. There's no need to go any further since the lines below are going to handle the valid key presses. If it's a movement action, again, we unpack action. Now that we arrive at the interesting part, if the action is an instance of the class movement action, we need to move our at symbol. We grab the dx and dy values we gave movement action earlier, which will move the at symbol in the direction we want to move. Dx and dy as of now. It will only ever be minus 1, 0, or 1. Regardless of what the value is, we add dx and dy to player x and player y respectively. Because the console is using player x and player y to draw where our at symbol is, modifying these two variables will cause the symbol to move. Else if it's an escape action, ray system exit should look familiar. It's how we're quitting our program. So basically, if the user hits the escape key, our program should exit. With all that done, let's run the program and see what happens. And it already says that we're going to see something weird, so let's see how this goes. My God. We just made the snake game. Blah. I'm actually going to have a lot of fun drawing with this, so get ready for a 3-hour video. Now, I could hit the close button here, but I'm going to try escape because this is a chance for us to see whether or not the handler's working properly. Now, this is interesting. So there's a bunch of errors that are presented here. So future warning, console is deprecated. Replace tcod console with tcod console.console. I'm actually going to take the time to put these changes in now. So future warning, key constants should have been replaced with enums. Tcod event kwrite should be replaced with event keysymwrite. Okay. I realize this isn't the most exciting thing to do, but the last thing I want to do is have a program tell me something's going to change and then not follow up. Did it actually do it for all of them? Yeah, it looks like it did. Okay, so those are all the warnings. Now again, this is partly from my time working at a statistical agency. I ran into a lot of programs where there were warnings or deprecations or things like that. And these would be really, really old programs. And we were, I mean, like, the program that we were using made a really strong effort to keep things backwards compatible, but they put those warnings in for a reason. And it really drove me crazy that people were not putting those fixes in, because like it's telling you, right? One day you're going to upgrade and there's going to be a problem. So I sort of have this tendency. I know I talk about like writing Kleenex programs and stuff like that, but the thing I cannot stand actually is to see warnings that I don't address. So I realize that's annoying and I'm wasting time doing this, but I feel this is something worth solving. So we dealt with the console. We dealt with the key constants. Let's see how this goes. So first of all, we want to make sure, oh, here we go. It's not clear what buttons I'm pressing, but I definitely messed up in terms of replacing the letters. It's not moving consistent, but the escape works. And we don't have any warnings left. So let's just make sure. My God, what was I thinking? Okay. Warnings dealt with. So what's happening here? I want to try and not go too far down the screen because I realize that there are a couple of cases where I've anticipated what was said. I'm sure to an outside viewer, it looks like I'm just pretending not to know something that's coming up as I'm reading it. Some of these things, like I like that they're explaining these things, but I think talking this stuff out and seeing whether or not I understand what the program is doing is helpful for me in terms of understanding. So I hope this doesn't come off as artificial, but I'm trying to get a little bit better in terms of presenting. So in this case here, I'm imagining there's some sort of refresh that needs to happen. Essentially, right now it's displaying things, right? It's saying print on here, but it's not saying print a blank screen in place. So I'm assuming there's some sort of refresh or clean that needs to happen. Unless you're making a roguelike version of Snake, how original. And who knows, maybe you are. We need to fix the @ symbol being left behind wherever we move. So why is this happening in the first place? It turns out we need to clear the console after we've drawn it, or we get these leftovers when we draw symbols in their new places. Luckily, this is as easy as adding one line. Root console clear. I'm kind of curious. I mean, I guess you don't want to overburden it with unnecessary actions, but I'm actually wondering why this convention exists. All right, that's it. Run the project now, and the @ symbol will move around without leaving traces of itself behind. That wraps up part 1 of this tutorial. If you're using Git or some other version of version control, and I recommend you do, commit your changes now. If you want to see the code so far in its entirety, click here. So we are going to make sure that the program runs one more time. Yep. So pushing a bunch of other keys. If I hit numlock, does that change anything? Nope. Escape. All right. So that was fun. If we take a look, no problems in there. So we've got stage the changes. If you hit the commit button and there's no stage changes, VS Code will actually say, do you just want me to add everything for you? But it's nice to try and do this stuff properly. So add input handler. Error movement. Commit. And because we're at the end of the episode, we're going to sync these changes as well. All right, so that's the first run through the RoguelikeDev does the complete roguelike tutorial. This is what I should have done for Tuesday the 9th. I don't know, so it will start in 1 week on Tuesday the 9th. The goal is the same this year. So I guess in this case here, I should have been doing this between July the 9th to the 16th, and then presumably on the 16th, presumably everybody's doing parts 2 and 3 now. So I suppose I've kind of found what my variation is going to be. When I start seeing sort of errors or warnings, I'm going to make the adjustments as needed. And then I think maybe another thing that I'll do, just for a little bit of a lesson for myself, I'm going to see if there is a way. I don't know if this is the standard way of handling this sort of thing in Python, or if there is another way that you can say, okay, here's a bunch of different things that can happen, and here is the result that I want. So I'm going to see if there's a better way than sort of testing the condition a bunch of times. I don't think this is bad. I just want to be clear, but I'm curious. Because I've seen people complain about this in, I think there was a really famous example for VVVVVV. Sorry, VVVVVV. Yeah. And I think there was another case where somebody had a similar construct. And the thing is like it's like I was saying before, the type of people who will tell you, oh, well, you don't count as, you're not allowed to have an opinion because you're not a game developer, right? Like, these are not people who we're spending a lot of time engaging with. Obviously, I mentioned them twice in a 2-hour video, so clearly they're living rent-free in my head, I guess. But, like, there's a certain point where you encounter these types of people and you really wonder how much time you really want to spend engaging with this sort of stuff. On the other hand, while I think the overwrought reactions are broadly unhelpful, It is still a less than... Okay, I wish people didn't behave like that, but knowing that this is a thing, it is an opportunity just for us to say, hey, is there a better way of doing this inside of Python? Now, I will say for this tutorial, it actually addressed the like double slash thing and actually pointed out how doing that could potentially make you vulnerable to another type of error. So I think that they've probably thought this sort of stuff through. But this is going to be an opportunity for me to walk away because there wasn't anything that was too confusing in terms of how TCOD works and all of that. I think I'm maybe just going to see if there's a difference that I would do inside of how to build this. And again, I don't want to get weird and wonderful in terms of making changes to the tutorial. I think getting through the tutorial will be enough for me this first time around. But if I can if I can learn a little bit about best practices, that will maybe be a nice little extension for myself. And in this case here, we did that by changing the key sims and then adjusting the console from tcod.C console to tcod console. All right. Thank you very much for watching. We will see you in the next part, which we'll do part 2 and part 3.